Let's talk about the code 1968 array with elements not equal to average of neighbors. It gives us integer array nums, and it says that all of the number are distinct, and we want to rearrange those kind of elements by positions so that for every element, it will not be equal to the average of its neighbor. So, for example, original we give 1, 2, 3, 4, 5, and he returned some array like 1, 2, 4, 3, 4, 5, 3. Well, see, originally 2 is the average of 1 and 3, and 3 is the average of 24, and 4 is the average of 3 and 5. But after rearrange, you will see no number is the average of its neighbor. And because the result may not be unique, just return any rearrangement of nums that meet the requirements. So we should think about some kind of strategies to get not equal. So there is one of the strategy which will be a good solution is that we put this array into two parts. One part is the bigger part, for example, smaller part. Another is bigger part. Then what we need is that for the smaller numbers, we always put on the even index. For example, there is 0, 2, 1, 3. And then for bigger one, for example, 5, 4, 9, 6, or those kind of numbers. Then let's put the smaller numbers in the even index. For example, index 0, index 2, index 4, index 3, right? And also put the bigger number in on the odd index. Well, see, doing like this way, for every neighbor, you'll see, because if this number is a bigger number, its neighbor will all be the smaller number. So that's the average will never be the bigger one, right? And if we select a number which is a small number, its neighbor they all fall into the bigger part. Of course, the average will not be the median, right? So by doing like this strategy, we can rearrange to get our array meet the conditions. So of course, to put these numbers into two parts, right? Smaller part and bigger part. And the way we do that, we can sort, right? But sort does not have good time complexity. So we can do a quick select. We just need to partition it to part, right? In the partition to the we select a index, the median, right? Just that will be the median. We'll say that is 2 over n minus 1, right? The index of the median. No matter it is the length of the nums is odd or even, right? And if it is odd, the first part will have one number greater than the later part. And for the median, it is inclusive. Okay. So let's write code for this, right? And we have int n equals nums dot length, right? So what we do is that we need to quick select in nums. And for quick select, we have a start index and end index, right? And at index where do the partitions, that is n minus 1 divided by 2, right? And then what we do is that we need to have result equals new int, and then we need to, after we partition the nums the nums array, right? We put the smaller part on the even index, and put the bigger part on the order index. And then I will write this logic, right? And return result. So first thing, we need to write a quick select. We'll have int nums, int start, int end, right? And also index. Well, say if this start is greater equal to end, we just return, right? Then what we do is that we randomly pick an index from start to end, right? So we have random if new random, and we'll have int pivot. So pivot will be the numbers that will be start plus random next int from end minus start. So what we do is that while we have use two pointers, int left equals start, and right equals end, right? So I say while left smaller equal to end, or say while left smaller equal to end, and nums left smaller than pivot. Then we can keep in moving left pointers while left smaller equal to right, and nums right greater than pivot. Can keep in moving right pointer. And when we move out of this two while loop, and if still left is small equal to right, right? That means for the number at the left in the pointer, we should put on the right. And for the number which the right pointer should put on the left part. Then we're going to do a swap. So swap that is temp equals nums left, nums left equals nums right, and nums right equals temp. And we'll have left move the left pointer, right pointer, right. So after doing jumping this out of the while loop, the index may still the left and the right pointer, right? So they are at this will be the left, and the right will be here, right? Left will be one index, the right of the right pointer. But our index is here, right? Possibly it is here. If the index here or here, right? It does not necessarily meet on the place where left and right pointer meets. So if it is here, we should recursively to call quick select in this part. If it is here, we'll recursively call quick select on this part. So what we do is that if index is small equal to right, because the right is on the one index left to the left of the left, right? So a quick select nums start right index. Then we'll have quick select nums left and index. So this is a quick select, right? Then after we do the quick select, right, if we include 0 to index or index median. Well, see, on the smaller part, the number will be greater equal to the right part number, right? So if it is an odd number, it will have one more. So we just need to place those kind of numbers from the um, even index. And after moving out of the finish the even part, then we go back to index 1 to place those numbers to the odd index, right? So we can write int t equals 0 for int I equals 0, I smaller than n, I plus plus. So I'll say if t is greater equal to n, right, then we'll have t equals 1. Then here we'll have result t equals nonce, right? And for t, every time we should move to index. So this will be the code. Let's see. It looks like right equals end while left is smaller than right. Okay, not end. It will be ON time complexity, and because we create a new result array, it will be ON space complexity. Actually, it is ON average time complexity because quick select to see the average time complexity is ON. The worst case will be ON squared, right? But what's the average rate is ON. Uh, Python code is very similar. Let's write Python code for this as well. Um, so we can write, for example, n equals length of nums, right? And a quick select. For example, we need from 0 to n minus 1, and need this n minus 1 double slash divided by 2, right? That is the median index. And we should have result equals this one multiplied by n. Then we're going to have t equals to 0. Therefore, I in range n. So I say if t greater equal to n, then we'll have t equals to 1. And we're going to have result t equals nums I. And for every I move one index, our t should move two index. Then we'll have left quick select. Should have start index, start index, and index, and index. So let's say if start is greater equal to end, we just return. And we're going to have a pivot equals nums random dot random int from start to end. Then we're going to have left right equals start end, while left smaller equal to right, and while left smaller equal to right, and nums left smaller than pivot. Then we'll have left increase by 1. And we'll say while left smaller equal to right, and nums right is greater than pivot. Then we'll have right decrease by 1. And we'll say if left is smaller equal to right, then we'll have swap, right? Nums left, nums right equals nums right, nums left. And we'll have left should increase by 1, right should decrease by 1. And after this while loop, we should still divide conquer to do if index is smaller equal to right, then we'll pick select from 0 to right index. And let's say if index is greater equal to um, left, right? Then we'll have quick select from left to the end index. So this will be the code. No. Okay. So this is swap quick select. T resulting. We should return results, right?